So this will be the moment of inertia for using the parallel axis theory, which is equal to 7 divided by 5 mr square. So after this one, let us look for a uniform solid cylinder. How this parallel axis theorem, it is very applicable for the for the solid cylinder, which contain the mass m and also the radius r. That is what we are going to try to demonstrate with it for the aim of obtaining the moment of inertia about an axis on the surface parallel to its length here. So we could say that a moment of inertia through an axis which is equals to the moment of inertia through the center, then we add it by md square. But we know that here we are talking for the solid cylinder. If we are talking for a solid cylinder, we know that we try to demonstrate on our past session by saying that moment of inertia through the center, it means at the center of this uniform cylinder here must be for the solid cylinder must be equals to 1/2 mr square. That is what we try to demonstrate for our past lectures. And here we could continue imagining like for the solid sphere by saying that this d must be equals to r, because it indicates where the ring, it means the elemental ring, is located on the rigid, is located through is located on an axis of rotation. That is what we try. So after this one, my dear student, let us simplify this source to get the moment of inertia, as we have been told that here the parallel axis theorem is very applicable on demonstrating the moment of inertia through of the different geometry like this solid cylinder. So if we simplify this one, how can we solve this one? Let us see, because we have the common mr square, and we have an operation here. Now we are supposed to factor out mr square because it is common. Now after there, inside the bracket, we should obtain that mr square bracket 1/2, then we add it by 1. Then if we continue simplifying, we should obtain that moment of inertia must be equals to 3 over 2, then we times it by r square. So there are so many questions you will be asked on this part here. You'll be asked that using the parallel axis theorem, prove that the moment of inertia for the solid sphere must be equals to 7/5 mr square. Or our question should be that another question, prove that the moment of inertia, prove that using the parallel axis theorem, the moment of inertia for the solid cylinder is given by 3/5 mr square. This is some question you could be asked on your examination. So you are supposed to follow very carefully so that you can gain more knowledge on how you can demonstrate the question like this one. So my lovely student here, let us go and see examples related with what we tried to see on our discussion here. And our example say that consider a uniform ring. Now we have the uniform ring of mass 20 gram and the radius 5 centimeter. Now we are supposed to find the moment of inertia for the ring about an axis passing through it is edge and the perpendicular to the plane of the ring. So how can we get the moment of inertia? So let us, my dear student, repeat again our question so that we can gain more knowledge on how we could answer this question. Our question said that imagine we have the uniform ring, and that uniform ring containing their mass which is equal to 200 gram, and their radius was 5 centimeter. Now how can we get the moment of inertia of the ring about an axis passing through its edge and perpendicular to the plane of the ring? That is what we could answer on our question. But on part B here, we were supposed to a part of the car mechanical linkage, figure number 4.13b has a mass of 3.6 kilogram. Kwamba if we leave for the car mechanical linkage, now we were supposed to consider our figure number 4.3 located on the money beam here, which contained a mass of 3 kilogram. So here we have only 2 questions as we try to see. And this question involves 2 figures. We should go and try to see these figures here. So it is moment of inertia I about an axis through the point P of 0.515 meter from the center of mass is I. So the moment of inertia through the center we have been given equals to 0.13 kilogram meter square. So what is the moment of inertia through the center about a parallel axis through the center of mass m, as we have been asking. Now, how can we get the moment of inertia through the center about the axis through the center of mass? That is what we are going to see. First of all, we are supposed to demonstrate our formula here. Let us demonstrate our given values, so that we have the mass of the uniform load and also we have their distance, their radius. Also on part B here, we have the moment of inertia through the point P, the axis of rotation, and also we have their distance. Now, how can we get the moment of inertia so about a parallel axis through the center of mass? That is what we are going to try to demonstrate. So let us try to answer this question, because our question is categorized into 2 parts. Now, the first part focus for the uniform load, and the second part focus focus for the uniform ring. Now, for the second part focus for the car mechanical that is what we have been told is mechanical linkage. So here, as we try to observe our figure, the first one represents the figure number 13 on our first topic, Roman A, and the second represent here the figure number 13 for our fourth topic here on Roman B. So my lovely student here, moment of inertia of a ring about its edge. So this represented the moment of inertia through its